properly? Okay. So let's start with the chapter that is combustion and flame, which was already continuing. Last day there was one offline videos for you on the Tuesday. You have seen it. In this video I have told you about the very small topic of that chapter, what is spontaneous combustion, what is rapid combustion. Okay. Now what is the difference between spontaneous combustion and rapid combustion? I hope you have seen these videos. So today I will repeat the definition first, just once a revision of that. What is rapid combustion? That is, just take with the example, that is the burning of liquefied petroleum gas. So it requires when fire, that is, you have to make it contact with some fire so that it get burned. Okay. And when it burning, it produces a lots of heat and it burns quickly. This is called the rapid combustion. Rapid combustion, example is LPG. Another one is spontaneous combustion. Spontaneous combustion, you can say it is forest fire. This is forest fire. Another one example, that is burning of white phosphorus. Burning of white phosphorus. You have the knowledge of white phosphorus. It is used in the matchsticks. And another one is that explosion, that is crackers. Rapid combustion, combustion in which a gas burns quickly producing heat and light. Combustion in which a gas burns quickly to produce heat and light. Example, LPG. Spontaneous combustion, a material burns to produce flame. A material burned to produce flame suddenly without applying heat. Suddenly without applying heat. White phosphorus, forest fire, etc. is the example. Forest fire. Yes, I am coming to your question. Let me complete first the definition. And last one is explosion. Materials burns or explodes by applying heat pressure. Okay. So these are the three types of burning: rapid combustion, spontaneous combustion, and explosion. Yes, now yes, burning of wax or kerosene in kerosene stove is also a rapid combustion. Yes, because when the kerosene burns, it produces, due to heat, it produces the volatile form, that means in gaseous form. So as it is gas, in the definition it is given that a gas burns quickly, so it is called as rapid combustion. Very good question, Anansu. Tapon, your question is not understood. Tube means which tube? Sir, in explosion, how did the sound occur? Okay. Now, sound is generally comes when we struck materials by another one. Suppose a metal rod is struck by some another one metal rod, then the sound is very quick, light sound is come. But what is the reason behind the explosion? That is, the sound is coming. Now in sound what happens? A large amount of heat and also sounds are coming. Now sound is due to the breaking of bond in a certain, because when we just assume as a dry leaf, when we press it by your hand, dry leaf, when we press it by your hand, one sound will come. It is due to the structure, bonding, the breaking in the structure. Now what happened in chemicals? It is at the same time a large amount of bonds are breaking and bonds are formed. So it is due to the bond energy which is coming out in the form of sound. Yes, explosive in explosion, sound is the compulsory. Now you can see that in the definition, in the rapid combustion, here in the gaseous form, and it produces heat and light. Next one, in spontaneous combustion, a material, it is not a gas. Okay. Now burnt is produced suddenly without applying heat. It is one of the characteristics of that. And in explosion, it is also the material, but here heat is applied. Next. Material burst by applying heat or pressure. Material burst by applying heat or pressure. It is the definition of explosion. Example, you know about it. It is the crackers, firecrackers, etc. Tire tube burst. It is due to the change in the pressure. Tapon, it is due to the pressure, because there is a strength of the tube. When it exceeds that of its threshold limit, then it gets burst. It is due to the applying pressure by the air inside it. So it is it a combustion? Is it a combustion? There is a any one of these, that is rapid combustion, spontaneous, or explosion. You can call is explosion, because here the gases inside in the tube and applying pressure. The pressure is given itself by the gas, so it call it explosion. It is not what was the question? Yes, so it is the explosion, not of the combustion. Rusting of iron is a slow combustion, yes, because here heat amount is generated. Okay. Now in fire extinguisher, not only in the fire extinguisher, when you see that in the gas is liquefied in high pressure, then when it releases its pressure, then the volume is expanded. So, it is a part of the cooling chemistry, that is when we applying pressure and getting release, then it produces the cooling effect. Understood? When pressure is released, volume is suddenly expanded and it cools down the atmosphere. Sound occurred, I have answered it. Sound due to sudden explosion of air. Yes, it is called another type of explosion. Yes, sir, heat from the sun or lightning may also cause spontaneous combustion. Yes, it is also one of the reason of that, that is the forest fire is sometimes due to the lightning and also the scorching heat of sun. Okay, you are right. Next one, Kinton rusting. Yes, it is a slow combustion. Topon, so it is not a combustion. No, it is explosion. Rusting of iron is a slow combustion. Respiration is also a slow combustion. Yes, in respiration, heat energy is coming out, so you can call it combustion. Combustion of glucose in our body. Yes, this phenomenon is same for refrigerators. Refrigerator also use the same principle. Okay. Okay, now I am moving to the next part. So, from that part, the question may comes that give the difference between rapid combustion and spontaneous combustion and explosion, rapid combustion and explosion. 3 questions may arises from here. If questions comes, you may write it in the paragraph format or in the differentiate format, that is by using 2 columns. Just only write down the definition and one example of it. Okay. So, write down the definition in the first and then one example, if the differentiation is come in between these 3. Okay. Next, okay, next coming to the flame. Okay, one question is there, internal combustion. Okay, internal combustion, it is a part of thermodynamics, that is not only thermodynamics, when some liquids or some gases are transferred, that is heat energy is coming out as the expanse of work, then it is called the internal combustion. Heating energy is coming out as the work done in the system, that is due to the work done on system or by work done on any gas or any liquids, then it is called the internal combustion. Okay, now what is flame? Now everyone have seen that when a candle burns, it produces a glowing flame. This is called luminous flame. Luminous flame. Okay. Now, what is the reason behind this flame? Now, when a substance or a material in contact to heat produces the vapor, in contact to heat it produces the vapor, and this vapor is burning, then the heat is coming out. Just for example, the candle, but we cannot see any type of flame when coal is burned, coke or coal, when powdered coke is burned, then we cannot see any type of flame there. So, it is not a part of the flame, it is only the burning, but when it produces some volatile gases or volatile compounds which burning ultimately, it is called the flame. So, flame is produces by the volatile substances which is produced from the materials in contact to heat. Okay. Just like the kerosene also burns, the Bunsen burner is the type of burner which we used in the laboratory, and it produces a lots amount of heat, and the region of heat is different because the topmost the outermost layer is around 1500 degree centigrade, and the inner core having a temperature around 700 degree centigrade. Okay. And it is burning with, yes, W equal to PdV. Mercaptan also flammable. Okay. So, if do you understand the flame? Next I will complete internal combustion, partial combustion, etc. Okay, next coming to the table 6.2. Now candle, it produces flame, magnesium it also produces flame, camphor also, kerosene stove also, but charcoal does not produce flame, because charcoal is itself burned, the carbon itself burned to produce the heat and light, but it does not produce any volatile substances. Charcoal does not produce flame, yes. Yes, when charcoal, that means I have written here coal. Now coal is a part, you know it is a fossil fuel. Now in fossil fuel, you can, if you observe it minutely in some pieces of coal, then you can find that some liquid part is there which is solid in nature, but it was liquid. This part is a part of the petroleum. Okay. Now when such type of substance is present on the substances, then it burns, and when it burns, then it produces volatile flame. Okay. So this is the reason behind the flame. And when the and also there is a we can say that some petroleum part is there. For this reason you can see that coal is just a shiny appearance from the from a distance. So for this reason a petroleum like substances are there in a very little amount, which is reason for the flame. Okay. Next, structure of a flame. No, this is not an internal combustion. It is, the combustion is due to, it is combustible in room temperature. Internal combustion is a part of the machine, heat engine, etc. How charcoal is made, you have known it from class 7, where how charcoal is produced. Yes, it was also discussed on the previous chapter, that is petroleum and etc. There is a chapter in your book, that is petroleum. It is due to the pressure and heat in the earth crust a long time before. Later on it will be discussed. Let us discuss now structure of a flame. I have written here, I have drawn here one flame, structure of flame. This is called luminous flame. Now when a flame of candle is burning in a glowing sense, it is called luminous, and the color of the flame is, we can say, the orange or yellow color. It is not exactly orange or yellow, it is having a particular color, but when you will see the color of a Bunsen burner flame, it is blue in color, and the inner core, there is a inner core and there are different layers. So the outer layer is called the non-luminous flame. Non-luminous flame, that is, it does not luminate. So, luminous flame, it is produces by the incomplete combustion. It is produces by the incomplete combustion, and it is produces by the complete combustion. Incomplete combustion and complete combustion. Lots of question is there. So, incomplete combustion, that is the substance which can burn, it not burning due to the any deficiency. It may be due to deficiency of the oxygen, or maybe the heat energy required is much more. So, for this reason it is not burning. This is the reason for luminous flame. And non-luminous flame, here the complete combustion of the substances. It is produced in the Bunsen burner. Bunsen burner is the burner used in the laboratory, and it is produced by the candle, kerosene, etc. Now, out of these region, that is, just for example, for the luminous and for also the non-luminous flame, the outermost layer having the more heat quantity, the outermost layer having more heat quantity, and for this reason your book has a context that the goldsmith uses the outermost layer to melt the materials, that is gold or the silver, etc., because the outermost layer contains the maximum heating region, maximum heat. Here also the maximum heat. Okay. So, the outermost layer having the maximum amount of heat energy, and the inner core having lower energy heat content, and the lower the inner core also called the reducing zone, and the outer layer is called oxidizing zone. Okay. Now, there are two experiments given, that is holding a slide of a glass above the candle's flame, it produces a black mark. It is due to the incomplete combustion. It is also to prove that the material does not burn completely. But if you hold any glass materials, a glass side above of the Bunsen burner flame, there should be no such black spots will be there. Okay, I am coming to your question. Next one. Okay. Now, in the picture you can see that in figure 6.13 the different zones of candle flame and goldsmith blowing through a metallic pipe. Up to this today, that is up to the goldsmith blowing through a metallic pipe. Okay, next day I will start from the context 6.6. What is a fuel? Okay, now just checking your question.